In everyday life, we often add some material, usually a solid, into a liquid so that the solid spreads out in the liquid and the solid eventually disappears. We call this process dissolving. The liquid which can dissolve another material is called a solvent, and the material being dissolved is called a solute. When a solute dissolves in a solvent, a mixture is formed. This mixture is called a solution. Matter is composed of particles. In ascending order of size, the gaps among particles of solid are the smallest, those of a liquid are larger, and those of a gas are the largest. For example, take a lump of sugar. When the particles of solute slowly come off and go into the solvent to mix with solvent particles, the process is called dissolving. If the particles of solute come off quickly from the solute and mix into the solvent, then the process of dissolving is faster. If we stir the solute, its particles may come off more easily. In other words, the solute dissolves more quickly. On the other hand, if a solvent is heated, its particles will be charged with more energy, resulting in a higher speed of particle movement. This speeds up the process of dissolving. If a solid solute is broken down into tiny pieces, more particles can flow into the solvent at the same time. This is another way of speeding up dissolving. Putting a lump of sugar into a cup of hot tea is an example of dissolving solid in a liquid. The tea leaf inside a tea bag contains solutes. When a tea bag is put into hot water, the solute dissolves in the water. This is another example of a solid dissolving in a liquid. Solutes can be liquids. When milk is poured into hot tea and stirred, it becomes solution. This is if a liquid dissolving in another liquid. Have you ever noticed these situations? They are all examples of a liquid dissolving in another liquid. Watch this glass of soft drink. Why are so many bubbles coming up? During the production process, carbon dioxide is dissolved into the soft drink. This is an example of dissolving a gas in a liquid. All carbonated drinks are produced by a process during which a gas is dissolved into a liquid. Now you see a solute can either be a solid, a liquid, or a gas. The production of soft drinks provides a very good example of this phenomenon.
Coca-Cola is produced with 3 solutes of different states dissolving in water. They are solid white sugar, concentrated liquid Coca-Cola, and the gas carbon dioxide. When all 3 are dissolved in water, Coca-Cola is formed.
Can you explain the dissolving process?
Basically, there are 3 steps. Firstly, we pour solid white sugar into a sugar dissolving machine. The white sugar will dissolve in water at about 30 degrees Celsius to form a concentrated sugar solution. In this stage, we will use a water circulation system to speed up the sugar dissolving process. Secondly, we put concentrated liquid Coca-Cola together with the concentrated sugar solution into a mixing tank. Treated potable water has been poured into the tank beforehand as a solvent. We then stir the materials to mix them together, and a soft drink syrup is produced. Finally, we add in carbon dioxide gas. Liquid carbon dioxide is gasified and added into the chilled soft drink syrup. The soft drink syrup has to be cooled down in order to speed up the process of dissolving carbon dioxide gas into the liquid. Coca-Cola is produced at this stage. The Coca-Cola product will pass down the production line to be stored in bottles or cans. After final packaging, it is ready for sale.
A fixed amount of solvent can dissolve a limited amount of solute. This limited amount is called its solubility. When a solvent has dissolved a large amount of a certain solute and cannot dissolve any more, the solution is called a saturated solution. Would you tell me what process you are doing right now?
We are now dissolving a chemical to make a saturated solution. We divide the saturated solution into two portions. We treat one portion with a quickened cooling process by putting it in some ice water. We keep stirring the solution to make it cool down evenly. We can see some small crystals gradually appearing. In the process, we can see that all crystals are formed at the same time. They are very small in the form of a powder. Another portion of the saturated solution has not been put in ice water, but placed on the bench and allowed to cool down slowly. This way, crystals can grow slowly. They are larger and have a clear geometrical shape. They are very different from the powder form crystals we produced earlier. Different crystals crystallize in different ways. Take this as an example. If we put a crystal seed into a very saturated solution, a crystal will grow outward from the seed. This process of crystallization is very beautiful.
Can you explain what a crystal is?
A crystal is a solid formed by regular and repetitive lining up of the basic particles of a material. Its size, shape and color depend on the forming particles. Besides, crystals are also affected by the process of crystallization. In daily life, we can also encounter crystals, like single crystal sugar, granulated sugar, rock sugar, salt, and MSG. And as examples of non-crystals, we have wood, paper, and plastic products. As the basic particles inside these solids are not well aligned, they are not considered to be crystals.
These shining precious stones are in fact natural crystals, but they are formed not by the ordinary crystallization of a solution. Instead, they are formed when lava cools and crystallizes.
For crystals to become precious stones, they have to meet 3 criteria. Firstly, the stone must be beautiful. No one would wear a stone for decoration if it weren't beautiful. Secondly, it must be durable. Stones with greater hardness do not wear down easily. Thirdly, it must be rare. Rarity makes things precious. For example, a diamond is precious because it's rare.
How is a precious stone formed?
To put it simply, a precious stone generally originates in magma deep underneath the Earth's crust. After the stone is subjected to a long period of high temperature and high pressure, it crystallizes and finally comes to the Earth's surface in the form of lava. When the lava cools, a precious stone is slowly formed.
How many kinds of crystalline precious stone are there?
Precious stones that are crystals are called crystal stones. These crystal stones are mainly classified under 7 systems. Cubic system, such as diamond, garnet, tetragonal system. An example is zircon, commonly called hyacinth. Hexagonal system. Green sapphires belong to this type of crystal stones. Trigonal system. Commonly known as corundum, examples are rubies and sapphires. Quartz also belong to this type, such as amethyst and citrine. Orthorhombic system, like topaz and peridot. Monoclinic system, like hard jade and soft jade. Triclinic system, like turquoise.
The beauty of crystals is indeed dazzling. However, apart from giving pleasure, do crystals have any practical uses?
Crystals have multiple uses. Take, for example, the quartz clock. When electronic current flows through a quartz crystal, a vibration at a specified frequency is produced. This vibration is used for calibration of time. Crystals are also used in scientific research and high-tech production. This chip used in scientific research is, in fact, a crystal. Crystals can allow light beams of different frequency to pass through. Take this chip, for example. In fact, it is a crystal of table salt prepared to a much larger size with a special process. Take a look at this laser. Here is a piece of pink crystal. When a beam of blue-green laser goes through the crystal, it emits an infrared laser. Applying infrared light photography, we can see clearly the path of the infrared ray. The photographic quality of a crystal depends largely on its structure. Not all crystals have these special photographic qualities.
We tend to choose water for the solvent whenever we think of dissolving something. Water indeed can dissolve a lot of materials. It is therefore known as the universal solvent. However, there are still a lot of materials that do not dissolve in water. We have to use solvents other than water. How do we remove nail polish? Using water? Of course not. This solution, especially used for removing nail polish, contains a solvent called acetone. Both acetone and alcohol are chemicals called organic solvents. There are lots of organic solvents. Chloroform can dissolve certain types of plastic to fix 2 acrylic sheets together. You need only wipe one surface with some chloroform and let it dissolve the affected part. Press together and let them dry. We are often aware of renovation work without actually seeing it being done. This is because the wall painting and floor waxing jobs often use volatile organic solvents. A solvent called thinner is often used to dilute paints. Thinner is also used for diluting floor wax. As these solvents have a special smell and are highly volatile, their scent can easily drift and be detected far away.
Some organic solvents are toxic and highly volatile, hence posing a health hazard. You must take special care whenever you handle these solvents.
Who is more prone to be poisoned through the use of organic solvents?
They're mainly workers in the following categories. Dry cleaning workers are in contact with dry cleaning chemicals. And garment manufacturing workers use similar solvents to remove dirt. The second category includes mechanics who use solvents to clean pieces of metal or machines. And paint manufacturers and workers using paint, especially those using spray paint. And floor wax. The third category is workers in printing companies, like offset and silkscreen printing workers. They often have to use solvents to clean printing plates, machines and silkscreens.
How do the solvents get into one's body to pose a potential health hazard?
Vapor from sprays or hot solvents normally enter the human body via the mouth and nose. However, cold solvents can also produce a lot of vapor, hence should not be overlooked. Another way is via the skin, that is, when the hands and arms are in direct contact with liquid solvents. Inhaling a high concentration of solvent vapor within a short period of time will result in acute poisoning.
What are the symptoms?
The symptoms include numbness, giggling, mumbling, staggering, coma, or even death. Meanwhile, solvent irritation can cause patients to suffer severe coughing, red eyes and sore eyes, rashes and scaling on the parts of the skin in contact with a solvent. Chronic poisoning will occur if a person is exposed for a longer period of time, continuously or repeatedly to solvents of a lower concentration. Depending on the type of solvent, chronic poisoning results in damage to the liver, kidney and neural system. It can cause anemia or even cancer. Some people may misuse solvents. They may be addicted to sniffing glue, thinner or petroleum. This can also lead to brain damage and death.
Can you explain the industrial safety regulations regarding the use of solvents?
For example, factories where solvents are used have to be equipped with good ventilation system. If the workplace has to be air-conditioned, then the ventilation knob must be switched on the fully open position so that there's a good exchange of air with the outside. Use the partial exhaust fan system to directly draw away polluted air if necessary. Workers should wear respiratory protective masks and protective garments so as to avoid inhaling solvents. Workers should not eat, smoke or sleep in areas where solvents are used. They should never use industrial solvents to clean dirt from their skin.
A lot of organic solvents are highly inflammable. When you are handling them, you should exercise the greatest care to avoid fire hazard. You should not light a fire or smoke cigarettes while using organic solvents. At the same time, you should not store too many solvents, otherwise it is likely to cause fire.